Today we're going to review a $15 USB logic analyzer. Welcome to Drunken Electronics. So I was looking on eBay and I happened to find a $15 USB logic analyzer. This is kind of awesome. Now I've always wanted an oscilloscope, but for what I do, a logic analyzer should work. Basically, I'm trying to analyze the communication between digital sensors and the Arduino or Raspberry Pi that I'm configuring everything with. Now, with Logic Analyzer just looks at the voltage changes between two states on a given input. Does this very fast. This happens to be an 8-channel USB analyzer, so it plugs into the computer, uses some free software, hopefully it's from China, and should let me see the communication pathways. Let's see if it works. So this is the logic analyzer that I purchased. 24 megahertz, 8-channel, 24 megahertz, 8-channel, 4-arm FPGA, M100 SCM. It was $15. It seemed like it was a good deal. Let's find out. So up to 24 megahertz, 5 volt input range, 5 volt, 3 volt, 2.5 volt, yada yada yada. Reviews, all 5 stars and 4 stars, so probably pretty good. And PulseView is the software. I know Soleil Logic is actually for the Soleil analyzers, and it's supposed to work with this one, but I prefer to use open source where I can. So this is the $15 USB logic analyzer I got off Amazon. Let's open it up and see what it looks like. So the logic analyzer, really flimsy, rattles around. USB cord and probe wires. No software. That's it. So, time to go to the computer, see what we can find, see if we can figure out how this thing works. Alright, so first we need to connect it using this generic driver. Shows up as a Soleil, which it is not. And first let's go ahead and disable everything except D2, which I have plugged in. And we want to trigger this on the rising edge. Actually, let's trigger on rising or falling edge. So this way we shouldn't get a whole lot of stuff in here. If I run this and I fire off my test circuit and stop it, we should be able to go zoom in. And here we have a test capture. Now PulseView apparently has quite a few options to debug stuff or to interpret. However, playing around with it, I don't know what any of these really are. So I'm going to say that this works and that trying to determine what this is definitely possible. What I'm trying to do is actually figure out how the DHT11 communicates, so I can kind of reverse engineer it. I understand I can just look at the libraries and see how they talk, but I kind of like doing things my own way sometimes. So this is a great start. It lets me see all the communication that occurred from the time that the temperature read took place to the time that it finished.